Eric? Okay, thank you. Andy Dolph. I'm an agronomist for Redox based up here in Washington State. I'm a tree fruit specialist. I work with GS Lawn Company as they're our main distributor in the tree fruit industry up here. Today's topic is nitrogen metabolism. Just for housekeeping here, for all of you that are on the call, please feel free to use the chat function at any time along the way here to ask questions. I have a panel of people that I'll introduce here in a little bit, and all of us will participate in answering any of the questions that you have. At the end of the session today, there'll be a slide that has contact information for me and also for Redox in general. And of course, you're welcome to follow up with any inquiries or questions that you have that come up later on as well. So Redox, for those of you that are not familiar perhaps, sustainable carbon-based plant available nutrition. Today's topic is nitrogen metabolism, as I mentioned, and its role in yield and quality. My goal today is to present a brief overview of nitrogen metabolism in plants and how we can use Redox products to manage it. And then I have a series of examples which will be supported by the group here to talk about how this technology is being used in the field to increase both yield and crop quality. And you should walk away from the session today with some ideas about how you can improve both in your cropping systems. So to start with, this is an illustration of a simplified view of the processes involved in plant growth. So sunlight energy combined with water, carbon dioxide from the atmosphere, the process of photosynthesis, which results in production of carbohydrates. Carbohydrates are then processed by the plant and used to create proteins, antioxidants to help the plant deal with all types of oxidative stress, and amino acids are produced when combined with carbohydrates combined with nitrogen, create amino acids which result in proteins, and this results in plant growth. In agricultural systems, we're accustomed to supplying fertilizer, most commonly in the form of nitrogen, potassium, phosphorus, to accelerate this plant growth process. And by and large, the results are positive. This results in better outcomes for farmers. However, as we learn more about physiology and cropping systems, it's clear that these traditional approaches to fertility have some missing pieces that we can address to improve outcomes even further. Many of you are familiar with Redox products and how they're different from traditional products. Most Redox products start as common sources of nutrition. Raw products, phosphoric acid, zinc sulfate, calcium carbonate. These raw products are then subjected to chemical reactions with one or more of 11 distinct carbon compounds. And you'll often hear us talk about Redox products as reacted products. The most common of these carbon sources are on the left of this slide here: fulvic acid, humic acid, amino acids, and a range of soluble carbon complexes. The reaction results are what is depicted in the larger panel. This is an illustration of the soil solution, a plant root, Um, so what we have are complex and chelated mineral nutrition. By forming these compounds, the ionic charge in the various ions is satisfied, which allows them to remain soluble and plant available. Okay, this is true either when these fertility inputs are applied to the soil or also when applied as a foliar spray. It's important to point out that the carbon components not only help in improving plant availability, but also are useful to plant metabolism. In fact, these compounds that redox products supply allow the plant to perform at a much higher level than with traditional fertilizers. And so what follows here is kind of an explanation of that process. When we apply redox products, naturally we expect to have a stimulatory response in the plant. This is not always measured as an increase in vegetative growth. Instead, we observe an acceleration in photosynthetic activity, increased respiration, increased production of a wide array of phytochemistry, including the examples that are depicted here, antioxidants, terpenes, phenolic compounds, etc. These are products of a secondary metabolic pathway that's activated when plants are under stress. Plants are always under stress. The degree to which plants produce these compounds is contingent upon both the presence and severity of the stress, and also whether the plant has the resources on hand to produce them. So redox products are really specifically designed to supply these resources to the plant. And when we're successful doing this, the result is a substantial improvement in plant performance, particularly as it relates to yield and quality. And I missed one thing here. Just go back to this real quick. In addition, if you follow the primary metabolic pathway here, you'll note that the carbohydrates are being combined with nitrogen and sulfur down in the corner here, right here. And this is involved in the production of amino acids and proteins. So in addition to stimulating this photosynthetic activity, carbohydrate production, the carbon components in redox fertilizers contribute directly to the assimilation of nitrogen and also the carbon-nitrogen balance in the plant. So that's a very important point. Why do we care about the carbon-nitrogen balance in plants? I think this is really a very fascinating topic. And while much of the science is very solid here, there are still matters of discovery around the specifics of signaling in plants and how they respond with respect to the carbon-nitrogen balance. What is known is that plant function depends on a very delicate balance between carbohydrate production and nitrogen uptake and assimilation, which is simplified in this illustration here on the left. This is from a review article that's titled Carbon and Nitrogen Nutrient Balance Signaling in Plants. And you know, if you're a plant nerd like me, you'll enjoy reading this. I think it's really fascinating. I just want to point out a couple of items here that are of interest for understanding the concept. And highlighted in the paragraph on the right is this statement that studies show that more than half of the transcriptome, so in other words, the type and amount of proteins that are produced by the plant, is regulated. It's regulated by carbon, nitrogen, and this balance of carbon and nitrogen. So this is really fascinating. And also, the paragraph notes that the carbon-nitrogen balance is directly connected to the formation of cell walls and the morphology of the plant. And this is something that most of us that are dealing with this out in agriculture can relate to. I mean, we see this in the field. It's certainly true here in the fruit industry in Washington State. So this slide's been around for a long time. What we have here is a depiction of the uptake of nitrogen and its fate in the plant. Typically, we're supplying nitrogen in the form of either nitrate or ammonium. It's taken up by the plant in either form. Nitrate is reduced by nitrite and reductase, and then by nitrate reductase, and then by nitrite reductase to ammonium. Glutamate and glutamine are the result of combining carbohydrate and ammonia, which then becomes the basis for all amino acid and subsequent protein production in the plant. In the absence of adequate carbon or carbohydrate, as you see here, nitrate is stored in the vacuole, and this results in undesirable, what is often undesirable plant growth and non-productive growth. And it also contributes to problems with crop quality and pest and disease problems. So in agriculture, we're interested in shifting this carbon-nitrogen balance to meet our goals for yield and quality. And this involves targeted application of fertility at key timings to shift the physiology of our plants towards more protein and more broad-based protein production. The expectation is an increase in chlorophyll and photosynthetic activity, increased fruit size, increased fruit set, increased tuber set, etc. And also we expect to see a decrease in free nitrate and vegetative growth that's associated with it. So there are several redox products that provide benefits. In fact, most probably provide some benefit in improving nitrogen metabolism. The two that I'm going to focus on today were specifically created for this purpose, okay? The first is a product called V55. V55 is a reacted phosphorus product, 25%. It's derived from phosphoric acid. It also contains boron, molybdenum, and zinc. All of these elements are essential to efficient nitrogen metabolism. V55 also contains soluble carbon, amino acids, which improve nutrient uptake and plant performance. The second product is called Supreme. This is the flagship nitrogen metabolism product from Redox. It's also known as Caliper up here in the Pacific Northwest, and as Turf RX Supreme in the turf market. What is shown here is the dry version, a 20-pound bag. There's also a flowable Supreme available. Supreme is a reacted product, has all the components of V55. It also incorporates potassium, copper, iron, and manganese. Supreme is produced using a proprietary fermentation process that provides a broad base of soluble carbon compounds in addition to the amino acid package. Supreme has really proven performance over the years in improving both crop set and fruit size in a range of different crops. And so that's where we're going to go now, is to talk about various experiences that we've had in the field and also some trial results. So I want to introduce my panel of agronomists here. I have John Kelly with us. He's our chief agronomist based out of Salt Lake City. I've got Jasmine Baird, who's my coworker up here in the tree fruit industry in Washington State, as well as Jeff Yoder, who is our field crop expert up here in Washington. I also have Eric Massey, who is our jack of all trades from the Mid-Atlantic region over in Michigan. And I have Jared Sanner from the San Joaquin Valley down in California. And so this is a replicated trial that was conducted by G.S. Long up here in Washington a few years ago. And I'm going to let Jasmine take over right now and let her talk about this. Go ahead, Jasmine.
All right, can you hear me okay? All right, I'm sitting up here above the Snake River, so I just want to make sure. So yeah, this was a trial done by G.S. Long a few years back where they looked at Supreme, and they applied 2 pounds at petal fall, and then again 10-14 days later. So this specific variety is Jazz, which is a little harder to size. And so each of these crates have the same amount of apples. And so you can see the ones on the left are substantially bigger. So we see the same effect on Galas and Pink Ladies, any of the varieties that are a little harder to size with those. It's just same 2 applications.
Awesome. Thank you. Okay, so a nice example on apples. Let's move on to a range of field crops here. Jeff Yoder is going to talk about this one. Go ahead, Jeff.
So this is a grower demo that I did, I think about 3 years ago now, on some hybrid seed canola. And we put on 1 pound of Supreme right at 1% bloom. Like Andy mentioned, we need that carbohydrate in with that nitrogen in order to build those amino acids and proteins. So our goal here was to put that nitrogen to work right at bloom so we could have more flowers and set more crop. So this is a picture from the pivot. We split the pivot untreated and then our Supreme side about 28 days after application. You can see we've got more flowers. And Andy, if you want to jump to the next slide. It translated to more yield. We didn't get hard yield numbers off of this field because the guy who was in charge of going out and destroying the pollinator in this hybrid field was off by a row in spots and he was right on in others. So we didn't have equal acres and there was no way to calculate how many acres we had on each side of the field. So I took some pod counts and I looked at the females as well as the pollinators because he also had trouble getting his bees to work early. So the pollinator has more success pollinating itself, where the females that are sterile, it takes a little more work to get those pollinated. So just some numbers seeing what we did. We had about a 9% increase on the number of pods per stem on this canola on the pollinator, even more drastic on the female, but I think a lot of that was skewed by our poor pollination.
Okay. Awesome. So a couple other items here. This is from one of your onion growers up there. Can you tell us what your program is?
So that picture of the canola has got a lot of traction with growers up here, just because if we can extend that bloom and give more opportunity to get that crop pollinated, we're going to increase yield. And we've seen that on a lot of seed crops up here in the Pacific Northwest, including onion seed. And this is a grower whose full program on onion seed, and he's using Supreme right at bloom to metabolize that nitrogen and put a lot of energy into the flowers. And then post bloom, we're adding dicap to keep that plant pumping and fill that seed. So this is kind of a full season-long approach where we're focusing on our phosphorus products for root development, as well as our calcium products for good scape strength and stalk strength, and then nitrogen metabolism and soluble potassium for set and fill. So we've seen this on the majority of seed crops that we work with up here in the PNW.
What seed crops are you working with besides onions?
Sunflowers, canola, carrots, onions, sugar beets, garbanzos, seed wheat, garlic seed, but that's not really a flowering one. Yeah, we've got quite a bit of seed crops up here in the PNW.
And the programs are similar on those.
Yeah, Yeah, my go-to program for a seed crop is a flowering seed crop is Supreme, right at about 1% bloom as soon as you start to see flowers out there. And then once you're done with pollination, coming back with DiCap to fill that seed.
Awesome. Okay. All right, next example.
So here are some russet potatoes that we worked with. And this particular variety didn't set a whole lot of potatoes. So what we did was we applied 1 pound of Supreme right at hooking, and we increased that set. This was another field split where we put it through the center pivot on half of the field and compared treated to untreated. Right at hooking, when it's setting that first set of tubers, we helped the plant metabolize that nitrogen, put it to work, and create more tubers. And then we maintained a good nutrition program throughout the season, because potatoes will abort tubers if you set more than your nutrition allows. They will abort some of those. So we created more, but then with other redox products such as DiCap, we supplied the nutrition to carry those tubers all the way through harvest.
Nice. Okay, thanks, Jeff. All right, so now we're going to move on to the Mid-Atlantic here. And Eric, I'll let you tell us what's going on here. There's another potato example.
Andy, do you want me to take this? Since you so inappropriately use my picture in the slide.
That's a good picture of you, John.
Okay.
Your internet's too slow, I think.
Okay.
Yeah, go
so
ahead.
I'll just go ahead. So these red potatoes, and when you say Mid-Atlantic, you really meant the Midwest. I just wanted to,
Sure.
yeah. So this is actually Northern Illinois. These red potatoes are actually destined for processing. Okay. And what they want is size uniformity. They don't want them too big or too small. And where we use Supreme in this case is exactly as Jeff Yoder described. Initial stages of hooking or tuberization will put out the Supreme. And I'll mention it doesn't matter if it goes through a center pivot or if it's sprayed on, the effect is the same. And by setting just a few more tubers per plant, we get more uniform distribution. And this is a complement to a program to really push for exceptional quality.
Okay. And I believe that Eric had some yield information on this, and it was really a substantial improvement in yield here, if I remember correctly.
Yes, I'm familiar with the situation, and very nice yield, and more importantly, the quality improvements were very, very noted.
Okay. Next example is another potato example for Eric. And are you familiar with this one too, John? Or I think the message here was that by applying Supreme at hooking, they were actually able to produce more potatoes.
Yes, I'm remotely familiar with this.
This more of the crop.
Yeah, and this is also in the greater Midwest. I believe this is in Wisconsin. And just note the size distribution, but the really nice uniformity. And that's one of the benefits of Supreme.
Okay. Blueberries. Eric, why don't you try again and see if you can explain this one.
And I'll take this one too, Andy, if you'd like me to.
Okay. Yeah.
Sure. Okay. First of all, Supreme in blueberry production, if you start at initial flowering, and and typically on blueberries, we use 1 pound per acre, and repeat that because you have it's non-determinate. So you have, flowers setting at different stages. So we spread that out, and a 3 application regime spread about 14 to 21 days each, starting initial bloom. We have data showing that gives us about 12% increase in berry side and overall yield. Now, this case we're looking at here, this has also been complemented with some additional inputs. But one of the great things you can do is, once you set this nice crop through calcium early, and this had calcium on it. If I know, I think I suspect where this is coming from, and then as the crop is sizing, we can add DiCap into the program to enhance size, bricks, color at harvest. So, but Supreme can play very nicely into that strategy.
Okay, thank you, John. And that's our segue into talking about some of these redox results, replicated trials that we have. And this one is another one on blueberries that was conducted down in California in Tulare County with a blueberry grower cooperator. Applications starting at bloom, as John did, every 10 days, 1 pound per acre of Supreme. And they're evaluating berry weight, berry quality.
Andy, I want to insert, because I am familiar with this trial.
Yeah, sure.
There were actually only a total of 3 applications. So these were done fairly tight on this variety, so 10 days apart. So started early bloom, 10 days, and so covered that bloom window.
And the idea is we're getting both berry set and berry size out of this. And this was the outcome. So Supreme improved the size of the blueberries by 12.7%, measured by weight. And so the graph represents the total of 200 berries in each treatment. So that was the outcome. A nice Okay, so next example here is on almonds in California. This is a third-party trial that was done by West Society Pomology Consulting in Stanislaus County. Applications made in the springtime during and the evaluation parameters were nut weight and kernel size in this example. There were 3 applications applied on this trial as well. And what we saw was an increase in yield by 30.3%. And interestingly, basically the same kernel size between the untreated and the treated sides. Supreme also decreased the number of blanks by 38.1%, which is interesting here. It's not a statistically significant result, but I think it's interesting to note this. This is something that's a concern. In this particular trial, the number of blanks was fairly low to begin with, but it's a nice trend in the direction that we'd like to see. Okay, moving on to some fruit crops here, starting with cherries. Let's see here. So I'm going to speed up here a little bit because the outcomes here are very similar with similar treatments. So we had 9 different cooperators in this trial. Washington, Oregon, and California were their locations. Acres at petal fall, and then again 14 days later. So we're looking at fruit size essentially on cherries, and this is what the result was. Supreme consistently improved cherry row size across the board with all of these different varieties and all these different locations by an average of 6.8%. So this was characterized by a marked increase in the 8.5 to 9 row cherry category. So on the larger end, as you can see here in this graph, in the much less desirable 10.5 row and smaller, the increase in yield was helpful, but really the change in the size of the fruit was what really was important to these guys. Because the larger cherries have much more value in the marketplace. So this is really a cool study. Moving on to pome fruit, replicated trials done by G.S. Long and the Redox agronomy staff up here in the Pacific Northwest on multiple apple varieties and pears. And outcomes, again, these were similar. So 2 pounds of Supreme at petal fall, and again 14 days later. Bartlett pears, we saw an increase in fruit size by 6%. And again, the size of the fruit is really important. It's more important than yield in a lot of cases, although it is a factor of yield. D'Angelo pears, we saw an increase on average of 7% in the D'Angelo pears. Suckle pears was close to 20% increase in size. And probably the most interesting for me anyway is this Gala apple trial. Peak size on 100s in the grower standard treatment to size 88. So it shifts the curve up a size, but it also, you have considerably more size 80s and 72s. So again, fruit size is really improved here, making the crop much more attractive to the market based on its size. And this is really an incredibly important feature in the market that we're in right now, Gala being the largest apple cultivar grown in Washington State. So we have arguably a supply surplus on that variety up here now. So size is really important. Back to California, a really cool study on pistachio. This is a great example of performance of Supreme in combination with another product that has been mentioned today, DiCap. Scroggs Consulting was the third party that did this trial. 4 applications, foliar sprays were applied. And it encompassed the bloom period and post-bloom. So 2 pounds each of Supreme and DiCap were applied, and there was a range of different things that were assessed here. The most interesting was just the fact that the average weight or tonnage per acre resulted in a $1,200 per acre premium over the control group. So at an average of $2.50 a pound, the return to the grower per acre was $1,200 higher, a very nice return on the investment in his fertility dollar there. And that's really, what we're all about here. That's what makes this work for all of us. So the lightning round, the last thing we're going to talk about today, the last trial. And this one is specifically a trial that was conducted using DiCap. So DiCap is also a reactive product containing 31% phosphorus, 50% potassium. DiCap's commonly used for issues in the abiotic stress defense category, such as heat stress, water stress. It's specifically formulated to increase plant respiration and photosynthesis. It also stimulates the production of antioxidants. Valley. And I'm going to pass the mic to Jared Sanner and let him take us through this trial.
Sure, thanks, Andy. Yeah, so this was DICAP's a natural fit for us in our almond market during that whole split to post-harvest, just for bud building, increasing plant respiration, driving carbohydrate storage for yields. And this is actually a benefit that it's been documented. I want to give credit here. The research that we'll look over is UC Riverside, Dr. Adescavage. There's multiple universities involved, UC Davis, Gradzel there, Stanislaus with Duncan, and UC Extension, Sutter, Yuba County, Inclusa, Franz Niederholzer. So there's several, and there's others that have been contributed. This has been looked at. We'll look at a 2-year data, I believe, that's cited here, but this has been, we just completed the 5th year that they've analyzed this. So what they've looked at is using DICAP at this whole split timing, 2 applications. It's at a 3-pound rate, and it depends on the year, but typically it falls in that mid-July, usually 2 applications in that July, sometimes early August, depending on the weather. Go ahead and advance it, Andy. So whole rot, there's a couple different types, Millennia or Rhizopus, and it takes opportunity. It's always present. It's in the orchard. It takes opportunity when that hole begins to split. It wants the water and nutrients in that hole. And so what we're looking at here is some information that's provided by UC Davis. We know if you are aggressive with your nitrogen, usually the vigorous orchards are the ones that deal with whole rot the most. And so it's been well studied that if you can watch your nitrogen inputs, particularly cut those back as you get mid-season, June, really watch that, you will reduce the incidence of whole rot. So we know nitrogen and weak cells, the pathogen feeds on that. So this is just referring to some of that UC Davis information that we know nitrogen plays a role here. So we want to facilitate that reduction of that and utilize that so it's not weak or easy food for the pathogen. So this is citing, I believe this is 17. Like I said, there's 5 years research here and very similar trends. They included it with their fungicides, which is obviously a common practice to deal with this in the orchard. But as you look at DICAP, when it's alone, and they've also looked at it adding to different high pH materials. We've seen some, whether it's an aluminum material, this calcium hydroxide, it actually, we see a lessening of the effect and the plant's ability to deal with that excessive nitrogen or heat stress. We feel there's a couple of reasons why DICAP's performing here, but usually the research I've seen in the last 5 years, 2 applications is a better effect in reducing that incidence, or strikes is what they're measuring here. The blue line is strikes, and you can see DICAP, both treatments will perform well there. And the second, it's an additional year here. I believe this is 18. You see that aluminum material. I talked about aluminum sulfate. Obviously, in that tank mix, it negated some of the effect. And we've seen that with other materials here and there that can negate the plant effect of DICAP. Here 2 times again, one of the outstanding performers here in reducing, and this was a particular bad whole rot year. You can see 35 strikes in the control, and down to, again, anywhere from 3 to 6 times. That 2 applications, you're near 5 strikes on average. So again, this has been a very good material to use. Twofold, it's nutritional, helps you build carbohydrate storage for, we get plenty of information on that, for improved yields the following year and maintain that, but also helping with this instance of where respiration, nitrogen metabolism is very important, and it's been good, and it's been practiced by many people now here in the Valley.
Yeah, I like this because it's a nice illustration of the role that nitrogen metabolism plays in helping the plant deal with a disease pressure. So this is an abiotic stress that we can address by providing nutrition to the plant, and the downstream benefit is a reduction in this what's essentially a biotic problem. So very interesting.
Andy, before you jump off of that, I would add what's hurtful in this. It does harm your harvest. It's hard to get the nuts off once the pathogen is in that hole, and they start to stick, and that makes it difficult. But what's worse is it travels, and you get dieback, shoot dieback, and then that fruiting wood is reduced for the following year. And so it's a severe thing. And nonpareils typically, that's one of our higher planted, the highest, so it's an important issue for us. So DICAP's been a good tool there.
Yeah, great. Good deal. All right, so that brings us to discussion, the general discussion. And these are the three products we talked about today. And I'd like to invite anyone on board here to forward any questions that you have. We're happy to answer any questions. And I also, if there are any other comments here from the Redox group, there were initially some people that were signed up that are on the turf side of the house that might have some interest in some of this stuff. And I'm interested in any comments people have on that. Okay, at this point, I don't see any questions. Let's see here. So where does Supreme have a fit in turf? And that's a question from one of our Redox guys. John, do you have a kind of a general overview of that?
Yes, there are fundamentally, you have two broad categories of turf grass. You have warm season turf grass that naturally is grown in the southern portion of the United States. An example of that would be common Bermuda, although there are many other varieties. Then you have cool season grasses, and examples of that would be Kentucky bluegrass, fescue, so on. And so Supreme actually impacts both of those in the different ways. On warm season grasses, one of the key benefits is that as the turf grass transitions from an overseed to the warm season grasses with an application of Supreme, it comes in much quicker and much more uniformly. On cool season grasses, perhaps one of the greatest benefits is when cool season grasses shut down respiration as the temperatures get hot, and poor nitrogen metabolism occurs under those conditions. And what you do is you get this weak, very puffy grass that's very susceptible to mechanical as well as environmental damage in general. And Supreme is a wonderful tool to mitigate that poor nitrogen metabolism and just keep the turf grass growing strong.
Nice. Okay. Thank you very much, John. Any more questions from anyone? Well, I want to thank you all very much for attending today. And I'd just like to say that for all of us at Redox, we understand that the environment in agriculture is really particularly challenging right now. Our sincere interest is in improving outcomes for you as reps and growers, and that includes working with you individually to help design programs that will really produce a clear return on the investment in your fertility dollar. When you're successful, we are as well. If you have any questions or comments for me specifically, please feel free to contact me via the email here, Andy Dolph at Redox, Kim com. You can call me on my cell phone, 509-308-5313. I'd like to wish you all a successful season, and thank you once again for attending today. Have a good day. Thanks, everybody. Appreciate your help. Thank you.